Good morning everyone, how are you today? Okay, so today we will continue our lesson, Newton's law of universal gravitation. We talked about the law of universal gravitation, FG, and about many applications, many examples, sorry. Today we will talk about application of this law. Okay, so we will see that because of this law we found an explanation for the ocean tides. You know that we have, girls, like ocean tides, we have high tides and low tides. We will talk about them today in details. Okay, so Newton's law of gravitation accounts for ocean tides. High and low tides are partly due to the gravitational force exerted on earth by its moon. So girls, if you remember here in this figure, we talked about the forces. We said that the earth exerts a force on a moon to pull it, and this force is exactly what causes the moon to orbit the earth, to go on an exact orbit. And this force, which is the centripetal force, it keeps the moon on its orbit. Okay, so we talked about the importance of this gravitational force exerted on the moon by the earth. So today we will talk about the importance of the force exerted by the moon on the earth. Okay, so I told you girls that this force, it's less obvious because the earth is much more massive. Okay, so this force which is exerted by the moon, it will not cause the earth for sure to go in orbit around the moon. So we know, girls, that the moon, it is the one that orbit the earth, not the opposite, because the moon is smaller. Okay, so its gravitational force, it's not enough to make the earth what orbit the moon. Okay, so put in your mind that smaller objects orbit bigger objects. So girls, the sun is bigger than the earth, right or no? So therefore the gravitational force exerted by the sun on the earth, it causes the earth and all the other planets to orbit the sun. Okay, and here, because the moon is smaller than the earth, so the gravitational force exerted by the earth on the moon, it causes the moon to orbit the earth. Okay, so we talked about this one. Today we will talk about this one. Sorry, this one, the force exerted by the moon on the earth. The moon at the same time is pulling the earth towards it. So this pull or this gravitational force, what can it do? We will see. It is the reason for ocean tides, or what's known about high and low tides. Let's see together. Okay, so here is the moon. So today we will focus, girls, about only on the pull of the moon. Okay, we will focus about this force. The moon is exerting a force on the earth to pull the earth towards it. Okay, so we will focus only about this, because the other one we talked about it. The pull of the earth, we talked about it. We said it is the pull that causes the moon to orbit the earth. It is a centripetal force. Okay, so today we are focusing about what? The pull of the moon, the pull that the moon exerts on earth to pull it towards it. Okay, so girls, this is the earth. The moon, it pulls the earth towards it. This pull is not very strong, but this pull it can cause ocean tides. Why? Because the water here on the surface of the earth, it will get affected by this pull, and we will have here a bulge. So this bulge, we call it high tide. So the ocean here, water will like stretch, will go outward a little bit because of this attraction. Okay, attraction or the pull of the moon. So we will have here this bulge. So this bulge, we will call it what? High tide. Okay, so now we understand that we have one high tide. طيب what is the reason of the other high tide? Why we have two not one? So why we have two not one? So pay attention. The moon is attracting the whole earth, not only this point. So this point we will call it the point A. The center of the earth we will call it the point B. And here the other side of the earth we will call it the point C. Okay, so point A, it is the closest point to the moon, so it is the one that will be attracted the most. Okay, so we will have here the high tide. Why it's the one that it will be attracted the most? Because girls, don't forget the equation. What is the equation of gravitational force? It is G, which is the constant number, mass m1 times mass m2 of the other object, divided by the distance between the objects squared, or r squared. So the closest the masses are, the stronger the force is. Okay, so here this side of earth will be attracted more than the center, more than the other side. Okay, so and what's attracted here exactly? The water. It's attracted because girls, water get affected more than rocks, more than earth itself. Okay, so we get here high tide. Okay, so at the same time the center of the earth, it's also pulled, okay, but not as strong as here. And at the same time the other side of the earth, it's also pulled. So we can say that what the earth also, it's pulled a little to the right because of this attraction caused by what? By the moon. So that's why here also what the water, the water here on the surface of the other side of the earth also bulges out. So we have another high tide. We have another high tide. So girls, because of the pull of the moon, because of the attraction of the moon, okay, because of the gravitational force exerted by the moon on the earth, we have two high tides and two low tides. Two low tides. So every you know girls that the earth rotates around itself. Okay, it makes one full rotation every 1 day, right or no? So every point, see this point will make a full rotation and comes back to the same position. So every point in the earth, okay, it passes through two high tides and two low tides. Okay, so every point in the earth, it passes through two high tides and two low tides. This is girls, it's we notice it where it's the most noticeable girls in Canada. There is a shore there, okay, it's called the Bay of Fundy. So there every 6 hours we can see a tide. Okay, why? So we have during day, what is the day? Day is 24 hours, right? So look for here, high tide. After 6 hours it will be low tide. After 6 hours it will be high tide. Then after 6 hours it will be low tide. Okay, I hope that you understand it. I will show you now a video so you can get it better. Okay, so two high tides per day, two low tides per day. Every 12 hours high tide. Okay, so high tide, after 6 hours low tide, after other 6 hours high tide. So see, after 12 hours we see the other high tide. Okay, after 6 hours low, and so on. I will show you the video now, so concentrate please.
With the moon, so the next day this shows 12 hours at the famous Bay of Fundy in Nova Scotia, Canada. It's the biggest tide change in the world. But what force could move such a massive body of water? Gravity. Here's the Earth rotating on its axis every 24 hours. We'll now draw the Earth as a diagram with its surrounding layer of ocean. And to the right is the silvery moon. Everything is attracted to everything else in the universe.
So this is what everything is attracted to everything else in the universe. It is Newton's law of universal gravitation. We said we have attraction between any two things. We can feel it if we are beside very huge objects such as planets. Okay, if we are beside normal objects, we cannot feel it at all because it's negligible. Okay, so everything is attracted to everything. The Earth is attracting the moon, and at the same time the moon is attracting the Earth
with the force of gravity. So the moon is attracted to the Earth, and the Earth is equally attracted to the moon. Notice that the two force arrows are the same length, showing that gravitational attractions are of equal strength. But we're only interested in the force on the Earth here. The moon pulls on the ocean closest to it and makes it bulge outwards. When the Earth rotates, the sea level is higher at this point in its rotation, causing a high tide. And a low tide where the oceans don't bulge. So you'd expect one high tide each day. But here it gets interesting because there are two high tides a day.
So it's not correct. If we expect that there is one high tide, it's not correct because in reality we have two high tides and two low tides. Okay, so here now they will explain again why we have the second high tide. Okay, so the first high tide is now obvious, girls. Because of the pull of the moon is exerting a force on Earth to pull it. Okay, so the ocean gets attracted. This bulge, it is the first high tide. Let's see now what is the cause of the other.
How come? This is because the strength of gravity is greater when objects are closer. We'll call the location of the ocean on the near side of the moon point A, at the centre of the Earth, point B, and at the far side ocean, point C. The strength of the moon's gravity is strongest at A because it's closest to the moon. So the part of the ocean that bulges towards the moon most is at A. But the moon's gravity also pulls on the Earth, moving it towards the moon as well. This has two effects. First, it makes another bulge at C. Second, it fills in the bulge at A, but not completely, because A has moved further towards the moon than B. Lastly, the far side ocean at C is also attracted to the moon, but it moves least because the moon's gravitational pull here is at its weakest, being farthest from the moon.
So here, at every point in the Earth, we have moon's gravitational pull. Okay, so the pull here is the strongest, the pull here is weaker, and the pull here is the weakest because it's the farthest point from the moon. Okay, but still we have it, right? So the Earth, all of it is attracted to the moon. Okay, so it the part here. So again here we have another bulge, which is the other high tide.
This leaves a partial bulge at C, though not as big as the one at A. Now we can see why, when the Earth rotates through 24 hours, it goes through two high tides and two low tides. But there's another surprise. By the time the Earth has rotated once and arrived back at its original position, the Moon has moved on a bit because it's orbiting the Earth at...
Okay, so here pay attention. Let's, for example, talk about the high tides the next day. Okay, so we know, girls, the Earth, it's making circular path around a point inside it, and it's rotating around itself. Okay, so it makes one complete rotation every 1 day, right? And the Moon, it takes about 30 days to orbit, to make a complete orbit around the Earth. Okay, so let's say now the first day the high tide was here. Okay, so the Earth has rotated once and arrived back to the same original position. But here the Moon is not here, okay, at this time. Why? Because it has moved a bit. It has moved at the same time because it's orbiting the Earth at the same time. So here we will not have the high tide. The Earth should catch up with the Moon in order to have the high tide. The high tide, where should it be now? It should be where? Here. Okay, so pay attention with me. The first day, for example, the high tide was here because the Moon was here, was in line with the Earth. Okay, so the Earth rotates around itself. So 1 day has passed and the Moon now, the Earth arrived to its original position. The Moon now, it's not here because it has moved a bit. Okay, it's now here. So to have the high tide now in this second day, the Earth will rotate, will complete its rotation until it reaches this point, okay, and catch up with the Moon. So here, what do you expect, girls? The high tide, the second day, will it be made like at the same time exactly of the previous day? No, there will be like a delay about 50 minutes. Okay, about 50 minutes. So the first day it was made here. Okay, the second day, because the Moon has moved, the Earth also has to move to catch up with the Moon. So the high tide the next day will be like 50 minutes later than the first. So we can conclude that we have a conclusion that we have 2 high tides and 2 low tides, not every 24 hours exactly, not every 1 day exactly. We have them every 1 day, in every 24 hours and 50 minutes.
At the same time. That means that the Earth has to catch up with the Moon, so the next day's high tide is about 50 minutes later. The Moon rises and sets about 50 minutes later too.
So this is everything for tides. I hope that you understand it. Okay, so you have here the explanation. I already said it, but if you want, you can read it. Okay, thank you.